So here we have a question which can be easy if you choose the right way, and it can be difficult if you choose the wrong way. The best way to go, first let me explain the question. The question has an elevator which is going up with an acceleration a that is equal to g, and there is a fixed wedge and a block of mass m at its top. This block wants to reach the bottom of the wedge. You need to find out the time taken for this block to reach the bottom of the wedge. So for going about this question, you can solve this question A with respect to the ground. But if you solve the question with respect to the ground, the question becomes difficult because you do not know the actual direction in which the acceleration of this block is in the frame of ground. But in the frame of elevator, you know where the acceleration of this block is. In the frame of elevator, this block moves in this direction. So we know the direction of acceleration of this object in the frame of the elevator. So it is best to solve this question in the frame of elevator. Now in the frame of elevator, we see that elevator is an accelerating reference frame. So to apply Newton's law in this frame, we need to apply pseudo force on all the objects on which we want to apply Newton's law. Here we want to apply Newton's law on this block of mass m. So we need to apply an extra pseudo force that is equal to mass of this object into the acceleration of the elevator in a direction opposite to the direction of the elevator to get a pseudo force of ma in this direction. There was already an mg acting in this direction and a normal force acting in this direction. This angle was theta, and in the frame of the elevator, we know that the acceleration of this object is in this direction. So we assume it to be a. Now we can write this as theta mass m, normal reaction here, and m of g plus a in this direction. The component of this force in this direction will come out to be m into g plus a sine theta. You should always remember, when you take components, you should take components in both the directions, and after drawing the components you forget this force. Therefore the component in this direction becomes m into g plus a cos theta, which is useless to us because we won't use it. We will use only an equation in this direction to solve the question. So while we write the equation becomes m into g plus a sine theta becomes equal to, let this be a dash, m into a dash. This m gets cancelled. A dash equal to 2g sine theta because a is equal to g. This becomes equal to 2g sine theta. Now we know the acceleration of the block in this direction along the incline. We know that displacement, initial velocity was 0, acceleration is equal to 2g sine theta. The displacement is equal to, this is h, therefore this is h upon sine theta. Displacement is equal to h upon sine theta. Let the time taken be equal to t. We apply s is equal to ut plus half at square to get s is equal to half at square. Therefore t is equal to 2s upon a root over. Therefore the time is equal to root over 2 into h upon sine theta upon a, where a is 2g sine theta. Therefore 2 gets cancelled. Therefore the final answer for time becomes root over h upon g into cosec theta. So this stands as the final answer for the time taken by the block to reach the bottom of the wedge. This question would have become very difficult if you would have solved it in the frame of ground.